Chapter 7, normal probability distribution. And we'll start, of course, in 7.1. This is the normal probability distribution. The normal probability distribution. Hope it didn't get attached to someone's in the back. Hold on. No, it's right here. I just decided to leave that one in the floor. I'm sorry.
Thank you.
You're welcome. Thanks for letting me go. So everyone, the normal probability distribution, we're talking about a bell-shaped distribution. Cool? We're talking about a bell-shaped distribution, which we've seen some of these before. But now we're going to talk about what's the normal probability distribution. And I'll actually give you a math equation for that curve there if anybody's curious about it. So you're familiar with this. Haven't we dealt with bell-shaped distributions already? Mm-hmm. Yeah, we already done this. So 7.1 today, you're going to notice, goes pretty quick. You're going to be familiar with this. I'll present it on the board. Section 7.2 is where we're going to focus a lot of time today. Okay? So I'm going to present a problem in 7.1. This is on page 368. All right? I'm on page 368. And they put down this bell-shaped curve, and they said a graph of the normal curve is given. This is number 26. There you go. The graph of a normal curve is given. All right, so here it is. And they already have this drawn. And you're familiar with this. It's like here in the middle, you got 3 tick marks here. 3 tick marks here, and then this thing really starts flattening out, but this bell curve really goes on forever. Well, they're defining this by the normal curve. They're calling this the normal curve. So from now on, previously we've been calling it a bell-shaped curve, and it is. You can keep calling it that, but we're not going to call it the normal curve. And if you're curious, like, does that actual curve, does it have a mathematical equation? A lot of you might not worry about it. Like, this is a stats course, this isn't a calculus course. But I know for sure there's students in this room who've actually taken calculus. I'd like to show that to you because I'm sure you're curious. So I'll make sure to give that to you anyways. So in this problem, they already put numbers down here. And they've got a -1 here, a 1, a 3, a 5. They got a 7, 9, and 11 here. And they did state, hey, this is no normal curve. You have to find that value and that value from this image. What's so interesting is that a lot of you in this room already know how to do this. Now don't worry if you're like, I don't know how to do this. We'll explain it. We'll explain it. But a lot of you are already familiar with this. This means the mean of the population, right? Mm-hmm. And there's the population. Just drawn it. These are really, if you think about it, you go, I thought you'd have a histogram here. Yeah, but this is just a representation of what histograms would look like. All right? There's a lot of bell-shaped distributions in this world, like the weight of babies, the height of men, the height of women, etc. But from here, we got to get the mean. And remember, this is the population standard deviation. Okay? The mean, where should that be?
5.
Right in the middle. So don't agree the mean is 5. Who knows how to get this? Ooh, oh.
It's 2.
2. She says 2. Excellent. How'd you do that?
Because each standard deviation is 2 apart.
She goes, each standard deviation is 2 apart. So you can simply, to get this standard deviation, you can go anywhere in this image and take a number on this, at that location, and subtract the one previous to it. And the difference right there is 2. So you can take this 3, subtract 1, and what do you get? 2. Or you can take the 11 minus the 9, you get 2. We're talking about that's how the standard deviation is for that entire image right there, for that distribution. Cool? Hey, since this was so quick, I thought we'd extend this problem. So I'm going to go in here. I do want to point out, what are these numbers? These numbers here, when the -1, the 1, the 3, the 5, the 7, 9, 11, they represent something. I'm going to put X. There's some X values. They really do. When these are real life problems, they represent something in real life. Maybe the heights of men, right? Like it could be like 58 inches or 62 inches in height, etc. They could be the weight of babies, maybe like 3.3 pounds. These look made up, do you agree? It looks like the author just made up these numbers. Do you agree with me? I mean, I don't know what would go next. You know, I'm thinking maybe it's temperature in Celsius, but they do look made up. Anyways, but that's what they are. These are X's. So underneath it, I'm going to change colors. I'm going to go back to something you're familiar with, z-scores. Now we haven't done z-scores for a while. So don't worry if this is kind of like foggy right now, but you'll see this day after day after day from now on, so you'll get very familiar with this. Do you remember what z always equals in the middle?
0.
0. And don't worry if you didn't know that. Trust me, you'll know from now. You're like, what's the z-score right in the middle of the mean? Z is always 0. It means it's a z-score of 0. You're right at the mean. Z-score here? 1. A z-score here? 2. The z-score here? 3. These just go
Negative.
negative. So over and over and over on every problem we'll be doing, this is how we'll be thinking. Oh, there's some x values here in this distribution, in the real life problem. But you and I will be able to standardize them with these standardized z-scores. All right? Because do you remember the empirical rule that 99.7% of data in a bell-shaped distribution is basically between here? 99.7%. There's a small percentage that you go what? Beyond here. Those crazy outliers. Like we talked about the height of men. You might have there's a guy over here. This was the height of men. He's 7 feet 6 inches tall, right? Cool. So I always want you to think like this in terms of these z-scores. So right now in your notes, you can put down that we're entering section 7.2, and we're going to stay here for the rest of class. And this is a fun section. 7.2. It's the extension of this normal probability distribution function. Okay? So this you can call the normal curve. Now, is anybody in this class interested in seeing the actual formula for that curve? Some of you may not copy this down. I get that. You're like, I don't care about that, you know? But some of you may be curious. Like, this is actually a function here, this curve right here. I'll call it f of x, and it's 1 over the square root of 2 pi times e, I'll put parentheses on this, to the negative x squared over 2. That's really what's represented by that curve. What's interesting about this curve is we're going to talk about the area under this curve. And you know what the entire area under this curve is? If you go from negative infinity to positive infinity, I was just curious, did anybody in this class take calculus 2 before? They called it an improper integral when they had infinities. Well, the area under this curve, everyone, you'll understand this, is 1. Exactly 1. The entire area. If you go from negative infinity to positive infinity, the area inside here under that curve is equal to 1. And we use that in probability because probability, what's the most we can get? 1.0, 100%. Does that make sense? Mm-hmm. So we can use this in terms of like estimating what's the likelihood of this happening in a bell-shaped distribution. If the distribution is bell-shaped, what's the chances this could happen? You know, it's like today we'll do like pregnancies and gestation periods. And we're like, okay, what's the chances that her gestation period could be 270 days or more? And we can find the odds of that. Isn't that cool? Mm-hmm. Because the area under this curve is exactly what? 1.0. Do you mind if I just show it to you real quick? It'll only take a second.
Because that obviously probability adds up to 1? Is that why you are
That's exactly why.
Oh,
Isn't that cool? And that's why that was designed like this.
God.
And I just wanted to show it to you because there are a few students in this class or one that actually took calculus or calculus 2. So I want to point out that you don't have to do this. I already put that equation in there. Everyone see it? the normal curve, and I'm gonna go up and hit graph, see the bell shape? Well, there's a button on this calculator that actually does the area. So I'm gonna go down, see number 7? Angela, isn't that an integral? So I want you to integrate this, gonna find the area under this curve, everyone. And I wanna go from, let's say, I'm just gonna go from -5 to 5. And watch it shade. Here it comes. Ooh. And what's the area? It's gonna give me the area right here. What's that area? 0.9999999. Okay, what's the area under that curve? If you go on, I only went from -5 to 5, but if you go from -infinity to positive infinity, the area is 1. All right, so we can use this in terms of finding probability and chances of things happening, because we're only looking at a certain portion of the bell curve. Does that make sense? Cool. All right, so you're going to see the word area in your textbook. I didn't want area to bug you, because a lot of you work the textbook. Autumn, I know you do. You know, they say find the area. You're like, oh, they're talking about under that curve. Cool. Oh, there's other ways where you can write this formula one with these in it too. You can put it like divide here and divide there. I don't want to show that to you. But I want to show that to you. All right, can I erase that? I just thought some of you may be curious about that. Is there really a formula to that right there? Yep, that's it. That's it. So this is the standardized normal curve. We're now in section 7.2. Everyone, what we have to do is spend a good 10 minutes. This will be fun. And play around with the calculator. I want to make sure you're experts with this calculator before we do the application problems. Once you're an expert with the calculator, application problems are going to be a piece of cake. So I'm going to draw some bell-shaped curves on the board. You don't have to be perfect as a bell. And I'm just going to shade a certain portion. Let's see. I think I'll shade from here to here. Negative, and I'm going to give the z-score here. Now I'm going to make it up. Oh, no, that's z equal to -2.1 right there. And I'm going to go over here and I'm going to say this is equal right there, z equal to 0.8. And I'm going to shade inside it. So let me shade inside this bell curve here. Now if I shaded the whole bell, do you agree I'd get an area of 1? Mm-hmm. All right. We're going to find the area between there using the technology. We're going to use a calculator. What did they do back 30 years ago, everyone? Like in my day, when I had to do this, I took this class. I had to look in the back of the book. They had tables. Are those tables still there? Yes. So if anybody in here prefers a table over the calculator, let me know. You can still look at the tables. We're going to use the technology because it's real easy. If there's one button, you're going to use it over and over and over again. It's called normal CDF. All right. And that stands for the normal cumulative distribution function, if you're curious. The normal cumulative distribution function. Why is it cumulative? Because it's cumulative. It'll sum all the region between the two z-scores. All you have to do is put your left z-score here. Lower z, or if you want to say left z, because isn't it on the left? So when you can write lower 0, then I'll put a comma. Then you're going to put your upper z. If you don't like the word upper, you could just say the right z. Then here you're going to have to tell me what's the mean z-score, and then here you're going to have to tell me what's the standard deviation of a z-score. Well, when these are going to be the same two numbers every time. Could you tell me real quickly in a bell shape, what's z equal to right here at the mean?
0.
So you know what you're going to put here every time? A 0. Every time. Because what's the mean of z? Right there. Z is always 0 right at the mean. What was the distance, Holland, between the two tick marks if you had a z equal to 0 right there? And what's z equal to right here?
1.
So what's the standard deviation of all z's?
1.
1 minus 0, 1. So every time we'll just put this. Cool? This is going to be real easy. We'll enter the left z-score and the right z-score. So we got to find that button. Do you remember where binom CDF was?
Yeah.
It's in the same menu. There's a menu called distribution. So would you go find it? I'll do it myself. I'm going to hit the lights. I'm going to go to second bars. Second bars. I should hit it on the poster. Second bars gives you distribution. D-I-S-T-R. Distribution menu. And I'm going to go there. And we're looking for normal CDF. Normal CDF, okay. Is it 1 or 2? Hey, if you're interested, never ever hit 1. I'll repeat that. Never ever hit 1. We're always going to use 2 over and over and over again. On your next test, you'll probably hit number 2 25 times. It's fun. All right, so we'll go in here. And what's my lower z-score there?
Negative 2.1.
Negative 2.1. I put the comma. The comma's above the 7. What's the next z-score? 0.8. I can just put 0.8, right? Make sure you get that little decimal point in there. Hit the comma, and then 0, comma, 1. Everyone, this should tell me the area under that curve. It's not going to be 1.0 because 1.0 would mean what? I shade everything. So this is going to give me that proportion of, and here's a new word I want to say, proportion. This is the proportion of the area under that curve. Because proportion, we can think probability, right? And how much is it? Ooh, what percent of that curve is shaded? 77%. 77%. And you can think of that as a probability. You can think of it as percentage. Isn't that cool? 77%. So what I'm going to put here, negative 2.1, 0.8. And we're saying, okay, you got 70.77. If you want to write it as a percentage, absolutely. Because we're going to be dealing with probability questions.
If the
77% of the babies that were born were between this weight and this weight. That's what we're going to be talking about. It's kind of neat. But it has to be a bell-shaped distribution, right? Not all distributions are bell-shaped. But weight of babies, height of men, height of women, IQ scores, things like that. Oh, go ahead, Art.
no, I was checking if the both the z's scores, the lower and upper are like same. The difference is negative 2.1. The other upper one is 2.1. Would it be 1 or not? The area.
Yeah, so if I did negative 2.1, and then,
upper is 2.1.
oh, let's see what we get. This should be very close to, he's just curious. This should be really close to 100.
100.
But it won't be 100, will it?
No.
100%. Let's see what we get. I'm just curious. Would you hit it? Tell me what you get. So now he's going way out here. Almost the whole bell, right? Because 99 point, you could think of the empirical rule between negative 2 and 2. Do you remember that?
Yeah, yeah.
95%? Does everyone remember the
95%,
empirical
yeah.
rule? About 95% is between a negative 2 and a 2? This should be close to 95%.
96.4.
And there we go. Makes sense. 96.4%. Cool. Hey, I bet you can predict this. What do you think would happen if I did? Oh, do you recall me talking about the second enter button? I'm going to do it again. If I hit second enter, it just shows what I posted previously, and I can go back and make changes. So I'm going to put negative 10. And then I'm going to write 10. Can you predict what you think the answer would be? Let me hit the light. What if I go from negative 10 to 10? Isn't that pretty far?
Yeah.
So shouldn't it really be really close to a 1?
Not 1.
1. And you go, well, theoretically, it's not the perfect 1.0 because you could have some crazy outliers, but this is probably close to 100%. I bet you a calculator will round it and make it a 1. Let's see. It sure did. Cool. Hey, I'll hit second enter. Watch how good you are. I just like this because it gives you meaning to this. I'm going to delete that and delete this. What if I only went from 0 to 10? In that I'm shading where?
So,
If I went from like a 0 to a 10.
so almost half of it, 50%.
Because remember, z equals 3 right here. These are z-scores.
Oh.
I'm going to start right in the middle and shade all that. Right? But you're only going out to 10. But see, 10's pretty far, isn't it? Because this thing gets really flat right here. What do you think this will come out to be?
Half?
50%. Yeah, let's see. I'm going to hit enter. Up, boom. 0.4999999. Yeah, it's 50%. Isn't that cool? So when you got it, I'm going to hit the lights a little bit more. So now, I'm going to keep this up all class. Normal CDF is the button. And we put in 4 things, right? This is the what? Lower Z. This is your upper Z. This is the mean of Z, which is always 0. This is the standard deviation for z-scores, which is always 1. Cool? Now, who's got the new calculator? What do they do?
You just put in the numbers.
she goes, you put them in vertically, right? They start with this. Do they call it lower and upper? I'm curious what they call it. Lower, upper. They use that, lower and upper. Cool. Awesome. Hey, some of you may be thinking this way. The designers of this calculator, they're like, come on now. If this is always going to be a 0 and a 1, then why do you got to enter it? So I do want it, and I should just whisper this as a default. Absolutely, everyone. If I just hit normal CDF, and I only did 0 to 10, and closed out the parentheses, I'm going to hit the lights so this shows up. Will as a default, the calculator will understand that what's going on beyond that, a 0 and a 1. 0 to 1, that's the default. So if I don't feel like entering that, this will still work. Cool? Do I get the same answer?
Huh.
So isn't that cool? Oh, I'll do that. Well, there's a reason I showed this to you. So I'm not wasting your time. I want you to do this. I want first of all, it's on the newer calculators. You were forced to do this. You got to enter some numbers there. Second of all, if you do this, I think eventually, especially at the end of class and next class, you're going to find out there are quicker ways to solve the math problems if you understand this concept. If you think, I'll just put the mean here and the what? Standard deviation here, you might find that calculator very useful to do this math. Sound good? So that's why I'm having you do that. So if you're like, why are you making me do this every time? I don't have to. There's a reason behind this. I like to get you in that, repetition and pattern. Cool? All right, so almost done, everyone. I just want to make sure you're an expert. Probably about 5 or 10 more minutes with the calculator. Here's my next example. This is 1.8 for a z-score. And I'm shading forever this way. And I want you to get the area under that curve. Or another way of saying it, can you give me the proportion? The proportion of that bell curve shape. The proportion of that bell curve shaded. I like to say that because we're thinking probability. Cool? All right. So, piece of cake. What's my lower z-score?
1.8.
1.8. Now everyone, here we go. We're all thinking, he shaded to here, but doesn't that mean shade what? Forever?
Mm-hmm.
What's the highest number you could think on a number line? Infinity, correct? Well, you can look at your calculators. Everyone, the TID 483 does not have an infinity button, does it? So what we're going to use is the number 1 times 10 to the 99th power. Does that sound cool? And I'll show you how to hit it on your calculator. So what we're going to enter for this one is we're going to go normal CDF. All right? The lower z is the number 1.8. I'll put the comma. We're going to use this number. 1 times 10 raised to the 99th power. I mean, that's a big, big number, isn't it? That's big enough. I'll whisper. If I just used 10, it would have been fine. But I like to exaggerate this. So I encourage everyone to do this. It's a good, once again, thing to get into in terms of repetition. We'll always use this for our positive infinity. And then I'll put my 0 and my 1.
1.
So I'm going to show you how to find that big E. That big E means 1. 1e99, everyone, means 1 times 10 to the 99th power. It's huge. It's a very, very, very big number. You know? So I'm going to use that in a calculator. How do you do that? All right. So let me get on here. Just going to hit the lights so you can show you how to find that funny big E. All right. So I'm going to go to normal CDF. Number 2. What was the lower z? 1.8. I'll put the comma. And now I want to type 1. Everyone hit the number 1. And would you hit, it's above the comma. Above the comma, so I have to hit second comma. Okay, I'm going to show it on that poster too. Second comma gives me that big E, uppercase E. And then I'm going to put 99. And then comma 0, comma 1. And I'll hit enter. And this will give me that probability. I'll hit enter right now. Now if anybody can't find it, I hit second comma to get that. It says double E, EE, it's 2 capital E's there, but it's going to give you that scientific notation. That's what's putting it in, scientific notation with times 10 to the power. It's just huge, right? Awesome. So what's the proportion of that bell curve shaded? Close to about what percent?
3%,
Yeah, about 3%,
3.6.
3.5%. Question? Someone had their hands up.
Usually what I do is I just put like a bunch of nines in it, and he got me the same exact answer.
I love it. Everyone, I love it. He's like, if I just put 10 here, I think I would have been fine. Do you agree? Seriously. But he goes, you know what I do? And I like your point, right? He goes, I just put a bunch of nines. You know? Because the minute you're over a z-score of like 9, you're good, right? Hey, the only thing is that when we get to those shortcuts, I still think you'll be fine, but when I get to those shortcut buttons, be careful if you're dealing with something. I'm thinking in real life, if you're dealing with something like in the millions, like, you know those X I use? If somewhere was in the millions, then you're going to want to use something way, way, way bigger. Okay? So there you go. But I love that idea. Because I just hit a few 9s and I'm good. All right. So great job with that. And when the answer came out to be about 3.5%, right? Almost done. We've done in the middle. I've done the right side. Well, how would you calculate this area? Or I could say this probability. Because later on, these are going to be dealing with probability questions. So how can I find that area of the curve? I do have to give you a z-score, though. You know I'm making this up. Does this z-score, does it have to be positive or negative?
Negative.
Because of my image, right? So I'm going to make up a negative z-score, something over here. How about negative 1.6? So how would I do that? How would I do that?
Wouldn't that be your upper score?
All right, I love it. So when you look at this, the shaded region is important. I use my left hand and my right hand. We're talking about that region right there. So my left hand is the lower. So what do you think I should use for my lower?
Negative 1 e to the power 99.
I love it. So for this one right here, I'm going to use negative 1e99. Ryan just put a negative and a few 9s down, right?
Mm-hmm.
Boom. What's the upper? You hit it, Randy. The upper z is negative 1.6. And then you get your 0 and your 1. This is the mean of z. That's the standard deviation of z. This time I'll let you do it. It shouldn't be much. What's the percentage? 0.055 of that curve shaded underneath. 5.5% shaded underneath. The area under that curve is 0.055 shaded. Cool? See, once you know how to do this, when we get the application problems, they're going to give you some real life numbers. Oh, the weight of the baby is this and this. What's the chances it could be a little bit higher than this or less than this? And we'll go, oh, let me standardize it with my calculator. We'll standardize everything. This is called, these z-scores are standard z-scores. We'll standardize. Standardized normal curve. Cool? So I think I've done everything. I did a left side, I shaded a right side, and I shaded in the middle. You're an expert, aren't you? Can I show you one more thing, though? And just put in your notes. You don't need this for test 4, but you will need it beyond test 4. So this is really for after chapter 8, but it's important. I thought I would show it to you now, and then when we get to chapter 8, when we get to chapter 9, excuse me, we can do this. So do you mind just putting in your notes? You can make a note like, I'm not going to let this freak me out now. Right? This isn't going to stress me out now, but, you know, at least I know what I could do if I was curious about this. Can you do an inverse operation? And you go, what do you mean? Could I go onto this board and just shade a certain portion? Holland, the last percentage, was it like 5.5%? So I'm going to come up with this. Oh, and this is 10% shaded. I shaded 10%. My question is, does that calculator have the capability of doing an inverse operation? If I get the percentage shaded, can it report to me the
Z-score.
z-score? And there is a button for that. But you won't need this until after test 4. Is everyone okay with that? Good. So you're like, all right, I don't need this. But it's called the inverse norm button. So to get the z-score, I hit what's called the inverse norm. And what you got to do is, right here, you got to hit the put in the decimal point, it's gotta be a decimal,
So
on the percentage
0.1.
shaded from the left, as a decimal. In terms of that area, percentage shaded from the left. But when you type it, everyone, how do we write percentages on a calculator? We write them in decimal form, right? Without that, 10%. How do you write that as a decimal? Is that 0.01 or 0.1?
0.1.
0.1. So I'm gonna make this decimal point really big so everyone can see it. 0.1, right? This is what shaded from the lower side. So I put left, but you could think from the lower end. The lower end. From the lower end. Okay. Negative infinity. Guess what goes here? The mean of z, which is standard deviation of z, which is. You know what the default is? What if you don't type these? We'll still do it? Yeah, good, yeah. You're like, I don't feel like typing this. Okay. That's the mean of z, that's the standard deviation of z. There's a reason I'm doing this. You might find it easier to do it another way in a second. All right, everyone, do this on your calculator right now. I'll do it too. Can we make a prediction? Should this answer come out positive or negative? Look at the image.
Negative.
Everyone agree? We know that. We're like, we should get a negative result. It's a z-score on the left side, right? All z-scores on the left on this lower side are negative. So, let's see where it is. Where's the inverse norm button? Oh, that same menu. Go back there. Where is it? Here, I'll clear that out. Oh, it's number 3. I even capitalized the N. And I just put 0.1. You can hit enter right now, it'll work. But I'm still going to put comma 0, comma 1. Just to emphasize mean is z. Because later on, here's my point, everyone. You might get tired of doing this. You'll shortcut your problems and go, can I just put the x values in there? You can. The calculator will work that way. It's pretty cool, but that's advanced technique that I want you all to eventually learn and use. But when you do that, you got to make sure you put the mean of the x's and then the standard deviation of the x's. So everyone, I mean, think about it. Do you really think the mean of the weight of babies is 0? No, right? So that's what I mean. All right. Negative 1.21? There you go. Cool. Hey, I'll try this real quick. This is where I need you all to brainstorm. Then how, and when this is the only button on the calculator that gives us z, inverse norm. So how in the world, if it's designed to shade from the left side, how in the world could you find this?
It's a positive.
Watch, people are going to have some ideas. So when you're going to help brainstorm, everyone in the class, just brainstorm. What if I put here, and this is 22% shaded. Now you know what? I'll keep it simple. How about just 20%? Not drawing a scale, but what if I shaded 20% on the right side? And I need the z-score right here. Well, this is the only button you can use on the TI-8384. So I need some ideas because you know the way this was designed by Texas Instruments, this only does the proportion shaded from the what? From lower end. So I need some suggestions. Art has one. What do you think?
1 minus.
Ought to work. You're saying type in, put this in there, and you go subtract from 1.
1, yeah.
That'll work. I love it. I love that. Who's got another idea? Ryan?
Just put in 80%.
He says, look right here. And that's exactly what Art's saying. He said, right here. Ryan, very good. He goes, right here. Think to yourself, what proportion here is coming from the left side? And 100 minus 20% is, what's really in here? 80%, so you could just put a what? 0.8. Will that work? And remember, hey, autumn, everyone, just go, I don't have to worry about this till chapter 9, right? But isn't that cool? Now, here's what I want to propose what some students have told me in the past. Art's idea, Ryan's idea are outstanding. But you know what students once told me, and you may agree with this, they go, you know what I'm going to do? They're just going to type when they see this. By the way, what came out on the calculator? I'm curious.
0.84.
Oh, how much?
0.84.
0.84. That's a z-score, everyone. Be careful. Z-scores sometimes look like probabilities. That's a z-score. The z-score was 0.8. Now, you know what one student once told me when they saw this? They go, I'll just type 0.2. They know that the answer would give the answer over here. And they know the answer will be negative. So So I'll put a negative symbol, but they'll steal the number here. They just won't put the negative symbol down. Will that work because of symmetry? Absolutely. So if you like that too. So if I put inverse norm 0.2, the calculator is going to go negative 0.84, and you can just take off the negative and know that this z-score has to be what? Positive. Does that make sense? So some students do that. They go, I'll just put the number, but I know negatives and positives. Cool? And one more, and then we'll have some fun, do some application problems. One more with this, because I haven't presented this yet. And when this is for the inverse norm button after chapter 8. Ready? What if I shaded 90% in the middle? And I want both those z-scores. You've got to help me figure out a way how to do this with this button. So what I'm doing now, when I'm shading 90% of the bell curve, the normal distribution. 90% of the normal curve. Okay. So I shade it in the middle. And I want to know this z-score, which will be negative, everyone agree? And I want that z-score, which will be positive.
So 5, that should be 5, right?
So, oh, you're on to this. I want to use this button. It's the only button available on the calculator, but I have to put the percentage from the left side. So Art, very good, he's focused right in there. How could you and I mathematically figure out the percentage right there? Everything has to add up to what? 100%. So Art took 100% and did this mentally, I know. You subtracted 90% in your head, which gave you 10%. So when he knew that these two areas right here have to add up to 10%, right? But there's two of them, so he divided it by 2. And what's 10% divided by 2? 5%. So what's the shaded area right here? 5% shaded, and I'll just put in inverse norm 5%. How do you write 5% though? Is it 0.5 or 0.05?
0.05.
0.05. So let me get that out of the way. That's 5%. So I'm going to type that. Right? And I'm going to hit the lights, and let's see what the two z-scores are. You can do it too. Inverse norm 0.05. This time, everyone, I'm going to do it like, whoops. This time I'll do it like the default. Watch. Let's go. Number 3, 0.05, and I'm just going to hit enter. Because I know the default is I'll have to put that 0 and 1. What's the z-score on the left side?
Negative 1.64.
And I'll go out about 3 places, 3 decimal places. Negative 1.645, and the right?
Same.
The same. Because of the symmetry. It's all symmetrical. Ta-da! You are an expert with this calculus, with the normal distribution. So very good. I'm serious. That means you can do anything with this in terms of finding z-scores. Think about it. What did I have to do back in the day? I hated it, everyone. Every step problem, and you stuck your card back there and do that. Now, are there classes still taught like that today? Absolutely. I'm not making fun of them, but if they're doing it, that means they're not using a calculator, but they're probably using really neat numbers, so the z-score comes out to a really neat number. You can still do it. Some teachers still teach that way, but golly, use the technology, right? All it's doing is computing the area under this curve, like we've been doing. Uses calculus. All right. So I'm going to rate this. Now let's have fun. Real life stuff. Let's get to an application problem. All right. So when I was looking at this earlier today, and I'm like, what would be fun for this class? Anybody in this class going into nursing? See, I knew it, and I had a feeling there's a lot of hands going up. So I'm going to use a problem. There was one about M&Ms. Not M&Ms, Chips Ahoy. I'm going to leave that for you to practice at home. Cool. What they did, I teach at Naval Academy. Well, at the United States Air Force Academy, the cadets got together, got a lot of Chips Ahoy bags, the 18-ounce bag. Do you really think it has the exact number of chocolate chips in every bag? No, but they figured out after looking at all the distribution, it was bell-shaped, A lot of bags had chips around here, but there were some bags that had a lot of chips. I should go to this end. A lot of chips, and then there were some bags where you got gypped. And the cookies didn't have many what? Chocolate chips, and it was bell-shaped, okay? So that I'll leave for practice for you. I'm going to do number 41, it's gestation period. So this is on page 378. And in these problems, everyone, they have to tell you two very important numbers. They have to give you the mean, whatever it is, if it's normal, bell shape. They have to, oh, and here's something else. They have to tell you it's normally distributed. Some of them got to tell you that because unless we're aware of this, true? So they have to state that. They'll give you the mean, they'll give you a standard deviation somewhere too. So those two numbers are the important numbers. All right, here we go. The length of human pregnancies are approximately normally distributed. Check, we know it's normally distributed. The mean is 266 days. All right. I want to agree with gestation period. I always heard, what, 9 months? 9 months, yeah. The standard deviation is 16 days. And then they ask a bunch of questions. They're going to ask probability questions. But these have to be given. This is what I encourage everyone to do. The minute you get this, I would go off to the side of your paper. It doesn't have to be that big, and just draw an image of what's going on here. Because they did say this was normally distributed, right? And I would just go off somewhere and just go, okay, this was approximately normally distributed population. That's what you have. So you know it's a bell-shaped curve, representing what's going on with these pregnancies. And I would just go off to the side. It doesn't have to be that big. Look how small mine is, right? And I'm just going to leave it up here. But you know what I could do? I can make it big because I want to make sure all you in the back can see this. I'll use this one. And everyone go in here and let's just write a few numbers down. Okay? I'll get this out of the way. Who already knows what's right here?
Z 0 or
Oh good,
266.
z equals 0. I'll write that. But what's the x value here?
266.
So 266, right? I'll call it here, your x. You're my x value. My x, this one, x, 266. What's x right here? Do you remember how to do this?
Plus 16.
Yeah, the 16, which is
282.
282. That would be 282 days until the baby was born, right? Gestation period. How do I get this?
Plus 16 more.
298.
8.
All right. That's, if you want to do a third tick mark, you can. I just get the image going. I'll just go 2 tick marks out. What's 2 tick marks this way? We'll just see.
250.
250 and
234.
234.
cool. And hey, right underneath it, let's z scores. What's the z scores? Z score here, 0. Z score here, 1. Z score here, 2. Z score here, and we'll use this as a guide. Every time we do a problem, we can check it, kind of look at the image and go, am I doing this right? Why am I getting 99%? That doesn't seem right. There's a 99% chance a baby could be 200, gestation period, 298 days or more? That doesn't seem right. So we do that. All right. Letter A. The question is, and I'll write this on the board, what proportion of pregnancies last more than 270 days? What proportion of pregnancies last more than 270 days? All right, question mark. Maybe I want a chance to write that down. What proportion of pregnancies last more than 270 days? Hey, sometimes they word this question a little differently, so I want to present it that way. That way nothing tricks you on tests, right? I mean, it's like sometimes the wording's a little different, and we're like, this is going to mean the same thing. What if I said this? And when I went over to Anne Arundel Medical Center, and I randomly picked one woman, okay, who's pregnant, just randomly picked one woman who's pregnant from a list. What's the probability that that randomly chosen woman's gestation period lasts more than 270 days? That's the same question. Okay? So I'll repeat that, just so you know. It's like, I'm saying I randomly pick one woman who's already pregnant, right? And I go, what's the probability that randomly chosen woman, I randomly chose her, that her gestation period is 270 days or longer, right? Same type of question. So now, to answer this, we're going to do it in 3 steps. It's the 3-step method. Step 1, make a picture. And this picture is important. I want you to draw something. The bell. Draw a bell. So number 1, make a picture. Now I have a feeling after a while, because a lot of you do this, you'll make a mental image. You'll make this image mentally, and I won't even see. I go, gosh, Caitlin did this problem right, but I didn't see her drawing on the paper. That's okay. You probably thought of this mentally. What's in the middle?
266.
266 days. Where's 270? Off to the right somewhere? Yeah, so we just go off to the right a little bit. It doesn't have to be perfect. We're just like, well, 270 is over here. By the wording in this question, which way should I shade?
To the right.
To the right. Everyone agree? So that's what we're going to do. We're going to shade. And if you don't mind, I want you to do this over and over. Every problem. Make a picture. Shade. Which way am I shading? Right? By the wording. What they said less than. Okay, I'll shade that way. That's step 1. We're good there. Now step 2, you need to find the z-score associated with x equal to 270. I need you to find that z-score that is associated with the 270 days for this problem. And you go, we haven't talked about that all day. Well, there's a formula for it. And it's on the formula sheet. You've actually used it before, and I'm going to write it on the board now. Do you know, Art?
4 over 16 1/4, right?
That's right. That's exactly it. So I'm going to put this on the board right now. Hard outstanding. There's a z-score formula. Do you remember this? Z-score equals x minus mu over standard deviation. I can find any z-score with that formula right there. I'll enter the x value, I'll subtract the mean, the mu, divide the standard deviation. And I'll get that number Art just read to us. Every time. So you can use this always in this step right here. So what's the z-score equal to? X minus mu over sigma. X minus mean over standard deviation. So I get, what's the x value? 270. What was the mean?
266.
266. And then I have to divide the standard deviation, which was,
16.
and when sometimes this comes out with some long decimals. So if this comes out 8 places, I want to write every number. You know why? Because in mathematics, we never round to the last step. And there's going to be a step 3, okay? So I do want to emphasize that. Autumn, I know we talked about rounding. Don't worry, we'll let the calculator do the hard work. We'll let the calculator do the work. But if this came out like a bunch of decimal places, I'd write them all down. But this just comes out to be a what?
0.25.
So when I'm going to go in here, I just want to label it. Make it look pretty. That's an x value. And what's the z-score right there? Right at that line?
0.25.
Z equals 0.25 right there. At x equal to 270 for pregnancies, has a z-score of 0.25. 0.25 standard deviations above the mean. Okay. Now the fun part. This will give us our final answer. This is where we find proportion. And when this word, proportion, I'll box it off, means probability, means area under that curve if everything added up to 1. So to do this, to get my percentage or my proportion, probability, I always use the normal CDF button. Now, can you tell me how to enter the numbers? Proportion equals normal CDF. I'll put it right here in the middle so everyone can see this. Normal CDF. Boop, 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 boop. All right, here it comes. Do this is my 3rd step every time. All right. Isn't this mean of z, which is what? What's the standard deviation of z? Cool. This is my lower z of the shaded. What's the lower z?
0.25.
0.25. What's the upper z?
1E99.
1E99. Or if you recall, Ryan just hits 9 a few times. I think if you hit 9 once, you're fine. Because, right, Ryan, 9 standard deviations. My goodness, you're way over here already. You're good with probably 1 9, but this is really for emphasis, so we can encounter any problem with this. And let me know what you all get. This is what we're doing. We're going to do this over and over. Next class, same thing. We're going to take a brief break, one of these classes, and do some binomial distributions, maybe the next class.
40%, 40.1.
0.4?
Yeah.
40% of that shaded? 40% is our answer. So, hey Autumn, we've talked about rounding, I know. Here's the rule. Never round this number, ever. If this came out 8, I'll keep the calculator up there and let it do it. Then when I get here, I'll type all this out. I can round this to an integer, I can round this to, 1 decimal place, but it came out to be about 0.4. Cool. Awesome.
So the 0 and 1 stay the same even though we have an actual mean and standard deviation?
Yes, and I love it. So this is where I want to go, and I should label this. Holland has a really good question. Because Holland, you're going to start working these problems in a quicker manner. Because who likes shortcuts? So do I. You're like, if I can do something short, if I can get there this way, I'll do it. This is a 3-step process. You can eliminate step 2 if you want eventually. These were all z-scores. This was my lower z. This was my upper z. This was the mean of what? Z. And this was the standard deviation of what? But you bet. Guess how cool this calculator is. What if you put the lower x value there? And then you put the upper x, which upper x you could still use what number? 1e99. You could do it, but then here you'd have to put the mean of x and then the standard deviation of x. I thought we'd do that the last thing before you leave today. Is that okay? I like to do this over and over and over again because it's really based off standardized scores. But if some of you are so gutsy and bold, you're like, I'm going to try that already.
Oh, what
You can save a step.
Oh, so she's asking to put 266 and 16?
You bet.
Ah,
And
okay.
you know what's cool about it, Art?
Uh-huh.
You save a step.
Gotcha.
You don't have to go through here. And most of you, I bet when you're doing my test, that's probably what you're going to do, true? But I don't want to do it yet because if I do that, students can lose sight of the conceptual idea of what's going on here. We're doing this based off these z-scores, which were based off that funny curve right there that had a math element to it. That's how this is coming about. This is how we're doing it. I think if I rush that shortcut too much, students lose sense of how's this working? It's like magic, That's why I don't want to do it too quick, but you absolutely can do that. So when this came out for this one, let's try letter B. Letter B. All right, the question is, what proportion of pregnancies last less than 250 days? Oh good, I don't have to race much. Hey, less than 250 days. Okay, I gotta draw another picture. Bless you. I gotta do a z-score, so I'll do that again. And then I gotta leave the 0, 1 here, right? I'm gonna have to change both of these. Let me get those out of there, and it's gonna be a different answer, of course. Hey, are there any math geeks in here like me? Do you know how a mathematician or statistician writes this? They read this question out of the book. You know what they write? They go, P for proportion, X because they're X scores, and less than, what symbol do they put? That's how they write it. So if anybody wants to write like you don't have to write that to Autumn. I'm serious. But that's how math geeks write, true? They read something and they write stuff like that. You say, do you have to do that? No, but if you want to, maybe keeps you organized. Like the last one, I could have written P, X, greater than or equal to, and then you could change this to, in step 2, we're going P, Z less than that, right? That's what we're getting to down here. This is called standardizing. So we can get the actual estimated proportion. All right, everyone, I'm going to make a picture. Whoop. Where's 250? It's over here somewhere, right? Don't have to be perfect. And maybe over here, right? Which way do I shade? To the left. Because it said less than, right? how do I get the z-score? That's an x equal to 250. 250 minus 266 divided the, are you kidding me? This is coming out too neat. What is this?
1. Negative
Positive or
1.
negative?
Negative.
Good, and we expect that, and don't we expect a negative z-score? Keep in mind, Autumn, sometimes this has like 8 values after the decimal place. I would have written them all. So in it right here, that's x. Z equals negative 1 right there. Whoops. X equals 250, right on that line. So far, so good? Yeah? Everyone okay doing the math there? Hey, I shouldn't rush this. If you type all this once on a calculator, put your parentheses down. Some of you do this in steps, but put the parentheses around that numerator because of order of operations. I can't emphasize that enough. If you're like, oh, I got this down, make sure you're typing it like this, because if you just went 250 minus 266 division, it's going to follow order of operations and give you the wrong answer. All right. Everyone, this is why we make this image. Right there. What's the lower portion shaded?
Negative
Negative
99.
Randy, good. Negative 1e99. What's the upper z? A negative 1. Mean is z, 0. Standard deviation is z. If you don't want to type these, that's okay. What percentage of babies? 16%? So I'm curious, what came out? 0.16?
6.158.
Ooh, so in 0.158. But this is our final answer? So it's no problem, Caitlin, you get your final answer, you go, I can leave it like this? Absolutely, if you want to do everything to 3 decimal places. But you might just go, listen, I never rounded anywhere. I'm saying this is roughly 16%. That's how we speak, right? And when 16% of pregnancies last less than 250 days, you might know a friend who said, yeah, her baby was born, kind of early, because the mean is 266. Cool. Hey, we're going to go to the next one. What proportion of pregnancies last? Okay, we did a greater than, we did a less than. The next one says, you want to guess the word? Between. You knew it was coming. Between. All right. Between. What's the 2 numbers? Everybody see that book there? I'll look. Between 240 and 280. All right. What proportion of pregnancies last between 240 days and 280 days? All right. Make a picture. Where am I shading? Where's 240? Off to the left. Where's 280?
To the right.
To the right. Remember, this does not have to be the prettiest of pictures. We're just making some kind of image to represent this. Where am I shading?
In the center.
In the center. I can already tell everyone, do you agree? I'm not hitting any 1e99s or negative 1e99s now. All I need are z-scores. But in step 2, everyone, how many z-scores do I have to get?
2.
2 of them. I need 2 of these. So I might as well write 2 of them. I'm going to need a lower z-score and an upper z-score because I got to find 2 of them. All right. Well, if I put 280 here, and then this one I'll do the 240. And when I'm being honest, I'm going to write out every decimal, every point, every value that comes after that decimal place here and here. Okay? So what comes out on that calculator? I'm just curious. 280 minus 266 divided by 16. I'm writing it all out. I'm not rounding that. Because I'm in step 2. Don't round that early. And I get 0.875, right? That's the z-score. Right here, z equals 0.875. Now I'm going to do this z-score. Okay? Well, what's this z-score?
I think the same but negative, right?
Is it? Let's see, Art, maybe. Let's say no. And when I hit that, I like that second enter button. I gotta write all these numbers. I can't round. Negative 1.625. Never round to the last step. Never, never, never round to the last step. Okay. I got my two numbers. 0.875 z-score and a negative 1.625 for this z-score. Cool. So what goes here? Which number?
Negative 1.625.
Okay, 1.625. And what's this one?
0.875.
And what do y'all get? 0.757. Roughly 76% of pregnancies, huh? Isn't this stuff cool? Hey, I do want to make up letter D if you don't mind. Letter D says this. The wording percentile rank. So I'm going to show you that before you leave. The first thing is, before I show you letter D, there's two more things I just want to show you, and then we'll bust out of here. Here's the first thing. Who likes shortcuts? Okay. If you're like, man, I'm getting tired of getting these z-scores. You understand this is based on z-scores, right? But now that you understand that, you want to bypass this step? You can do it every time, but guess what you're going to have to put here? Your lower,
X.
x, your upper,
X.
x, the mean of,
X.
x, and the standard deviation of.
X.
And which step do you get to bypass? This, you can skip right over this with the calculator. Cool? So everyone, I have a feeling, some of you may go, yeah, I'm going to do that. Just be careful, right? What's the lower x value for this problem?
240.
240. Okay. What's the upper x?
280.
280. Now be careful, this isn't 0 anymore. What's the mean for these pregnancies?
266.
Ah, it's a 266. And then up?
61.
Isn't that cool? I mean, who likes that? And you go, oh, can I do that on a test? Yes. Can I do it on a test? Yes. You know, my only fear is if someone learned it that way, they might not understand conceptually this was based on z-scores. And now the last thing I wanted to show you today, everyone, I have to make this problem up because it wasn't written in this problem. What if they say, so if I call that, last one was C, right? I'm going to call this D. The wording is percentile rank. So here, I'm going to make this up. Last problem. Everyone, what is the percentile rank? Is the percentile rank, you've heard this before, you're like, what percentile ranking are they in if it's a bell-shaped distribution? What is the percentile rank of a gestation period, I'm just going to abbreviate, of a gestation period that lasts, let's see, how about 230 days? And I'll put a question mark. Get this out of the way. First thing is, we got to make a picture, right? We always make a picture. Here's what you do. Would you remember this for the wording percentile rank? You always shade from the left. You always shade from the left. For the wording, what is the percentile ranking? Because it always accumulates from 0%. Does that make sense? So if they say percentile rank, Michael, always go from the left side and shade. How far do I shade to? Where's 230? 230 is off to the left side somewhere, right? But hold on, when you go, what's the percentile rank? You'll see this on the chocolate chips question. You shade from the left, so when you get to this question right here, everyone, is that okay if we use the shortcut this time? Are you sure? I'm going to bypass step what? I'm not going to get the z-score. So what's this x value right there?
230.
Look at that image. Could you tell me the lower x, the upper x, the mean of x, and the standard deviation of x, and we're going to get the percentile rank, which will just be a percentage. just like before. Isn't that cool? But when I am bypassing, which step this time? Yeah. If you don't mind shortcuts, this time I won't get the z-scores. I get some students, you know what though? They always get z-scores. They like it. They get in the little rhythm. So here I'm going to do this step. I'm putting lower x, upper x, mean of x, standard. Now look at this image. What's my lower x? Negative 1e99. Some of you may be like, you can't have negative days. Who cares? This will still work. Right? Yeah. All right, what's my upper x?
230.
230. Mean of x, 266. Standard deviation. Now I'm curious because I don't know this answer. Tell me what comes out on your calculator. 0.012. Now, when I'll be honest, I am fine if you leave the answer like this on a test, right there. All right? I am totally fine with this. But the back of the book, who I call Bob, would write this as first percentile. That's how he'd write it. Or you know what? What if I get an answer like this? 5.2%, which is 0.052. Okay, you write 0.052. It's a percentile, you know, it's percent. The back of the book would say, it rounded to the 5th percentile. So if you want to write it like that on my test, I think it's great, talking in terms of an actual integer percentile. Now, I'm just curious what you all think. What if on a test, I give you a problem, and it comes out to be 5.5%? How would you all like to write it? Well, you could write 0.055. I'm okay with that. I understand it's percentage. But what do you all want? Do you want to say 5th or 6th?
6.
I'll accept both. Okay? So if you go, I'm going to round that down and say 5th percentile. Cool with me. You round up and go 6th percentile. I'm like, okay, that's cool. Sound good? Hey, everyone. Super duper job. Have a great day. Yeah, you like the shortcuts? Keep doing it. I'll hand you out a sheet eventually just to summarize this.